this year's uh, Industry Samurai Week. As you know, every year we discuss pertinent and topical subjects, and there is no subject more topical and relevant this year than the subject of semiconductors for the Indian industry. Arguably, this is the most important discussion of this week, of this discussion series. We have, and even better, we have prominent thought leaders, speakers from reputed organizations, and these speakers are thought leaders in their own right. We are talking about semiconductors. The subject does not need much introduction, but let me just give a little bit of a background as to where India stands now in terms of numbers. So Indian semiconductor market, as you know, is one of the world's biggest and fastest growing, with the projected domestic consumption of $80 billion by 2026. On the on the supply side, we still have to catch up. Um, on the trade side, India accounts for about 1% of global trade, and the country's annual IC imports, which account for how much are we importing semiconductors or chips. According to United Nations Comtrade database, it really went up. It leapt. It jumped in 2018 by 218% to 8 billion and further to $12 billion in 2021. We are going to discuss a host of issues. We've got an hour and a half and speakers who are going to tell us about the where we go from here. Let me introduce to you the speakers that we have today. We have Mr. Ashwani Agarwal, Director, Government Affairs, uh, just a second. Director, Government Affairs, Applied Materials. Applied Materials and every other organization on this panel needs no introduction, but it is my job to introduce it briefly to you, and I'll ask the gentleman here to elaborate more on their organization. Applied Materials, that everybody knows, is a global leader in materials engineering solutions that are used to produce virtually every new chip and advanced display in the world. We have Mr. Yogesh Umbarkar, Business Development Head Automotive, Sentient Corp. Sentient develops a digital neural decision processor and AI, artificial intelligence computing solution. It uses semiconductors to move machine learning from the cloud to the edge device, enabling artificial intelligence for sensor, voice, and video applications in most battery powered products. We have Mr. K. Krishnamurthy, who is the ex immediate past president and the CEO of IESA, which stands for India Electronics and Semiconductor Association. We have Mr. Pietro Casarola, Semiconductor and 3C Industry Manager, MAPOS, and from MAPOS, we have Mr. Hanish Arora as well, who's the Market Development Business Head of MAPOS India. MAPOS is a worldwide leader in measurement, inspection, and testing designs and manufactures a wide range of products and solutions, from precision measurement of mechanical components before, during, and after the manufacturing process to process controls and machine tools conditions. Very warm welcome to you, gentlemen, to be on our panel today. My first question to start with, to shape the discussion, is, and this is something that all of our readers ask us, is that where is India positioned on the overall global value chain of semiconductors, both in terms of where it stands in manufacturing to the timeline as to what has happened in all these decades. And I believe in the 1960s, the story goes, the word on the street goes that Fairchild was here looking to establish a fab here in India, which stands for fabrication. But that didn't work out. But I leave it to the gentlemen to give their perspectives on where India stands. Dr. Ashwani Agrawal, over to you, sir.
Hi, hi Anand. In words of the Prime Minister, yahi time hai, sahi time hai. I think we are riding the trust peak of the semiconductor industry at this point of time. If you really want to know where we are, if you actually need to do it, you need to dice it across the value chain. If you start by demand, we are a major consumptive demand economy, and that is a big opportunity for whatever can happen here. We have the designs for the demand, as Krishna, I'm sure will elaborate, India has a vibrant design industry, mostly MNC-led at this point of time, with emerging shoots of Indian IPR and Indian chip portfolio, design portfolios evolving, especially with the ISM initiative. So we should actually see a reasonable position evolve for design, from just being a software coolie to a software portfolio owner over a period of time. Uh, so it's good. It's there. It's a strength for us. The design talent is a big strength for us for our economy. Uh, then we go to the next stage, the die making. So from the design, if you go to die making, the die making base, the fabs are not there at this point of time. But that doesn't mean that we are at zero. Semiconductor Lab Chandigarh is a classic proof point that India can do it. My company, Applied Materials, is the world's largest tool maker for the semiconductor industry. We would have typical 50 to 60% share of any semiconductor fab you name in the world. Every fab maker, chip maker is our customer. Every chip you see in the world is touched by our tools. And let me tell you, my company engineers, when they visited SCL, they were surprised at what India had done. Okay. SCL Chandigarh is a proof point that India can do it. They actually do the design there. They make the die there. They make the device. The ATMP of that die is done there. And it's a classic positioning for India. We can do it. Okay. What we don't have is a coherent strategy to take it ahead. And then if you go to the device making, ATMP, the government strategy seems to have hit the nail on the head. We've got a good brand name, Micron, showing an interest in this area to the extent that they have committed a huge amount and they've got a factory coming up. But you know, they're not the first. The first has been Sahasa Semiconductors, who's already on the ground with their memory packaging units. Okay. Then to some extent, some people said that Micron is the first foreign player to come in OSAT out here. They're not the first foreign player to come up in OSAT. Actually, it's IDEMIA. IDEMIA has got their plant operational in August, but Sersa was operational in February and with their first commercial invoice. Our friends at IDEMIA are operational in end of August. CDIL is operational with silicon carbide device making in last month. Okay, so suddenly you do have all these green shoots emerging out, promising a good position for device making. Okay, so if you go the other way around, the last stage in this is the demand fulfillment. So we started with demand, it should end with demand, the key driver of an economy. So what is being made as a device should ultimately be integrated into a product which goes to a demand situation. I think we have that fourth D strategy also shaping somewhere loosely, but moving in the right direction. We still have miles to go on it, but the basics are there. That's what I would say at this end. Back to the group.
Thanks so much, Dr. Ashwani. That was really, really insightful. And you rightly said that we have the strength, we have what it takes. And the idea is to, and the need is to focus on our strengths and go from here. Krishna sir, my question is the same, that where do we find ourselves on the entire, not only the global value chain, but the entire timeline of the semiconductor industry evolution in the world? Krishna sir.
Thank you, Anand. I hope all of you can hear me well.
Yeah.
Thank you. So let me answer this question by putting just one file on the screen, which probably will graphically explain where we are as far as the timeline, and also as far as the readiness of the country in the respect of semiconductor, the entire value chain of semiconductors. So let me see whether I can bring that up. Give me a second. So there are many concepts or many viewpoints that are always being talked about as to whether India has caught up with others or missed the bus, or are we too late into the game? So I thought I will put the screen up with this one simple PPT, and I hope you are able to see this. And if you are able to see this, eventually all the electronic systems that we use, whether it's a phone or a laptop or a Wi-Fi router, or the electronics in the car, the infotainment system, the powertrains, even an electronic toy, at the end of the day, all the systems come out with multiple semiconductor chips inside that. Now, building these systems is what finally translates into a commercial business for a business enterprise. And that's where the economic impact, which Ashwini alluded to a short while ago, comes into picture. So just to put the numbers in perspective, today India accounts only 3% or contributes 3% to its GDP from the electronics. Though the consumption of electronics in the country is of the order of about $140, $150 billion, and is expected to go to $250 billion in the next 3 years, 25-26 financial year. And the semiconductor consumption, as Anand said right in the beginning, it's going to be $80 billion and going up to $110 billion. So it will become the number 3, electronics will become the number 3 importer of goods after oil and gold in this country. So from an economic stability point of view, this is not a very desirable thing to happen. So that's why this entire focus of electronics, particularly semiconductor, which is a building block, as I said earlier, becomes very, very important. Now look at this diagram, and I have sort of tried to draw the entire ecosystem in 3 rows. So the top row represents the design of a chip. So that's where a chip gets designed and it is committed to a fab or a fabrication foundry. The place where a chip is getting fabricated or manufactured is called a foundry. And the second row essentially represents what happens in the foundry. And the third row is where we get the wafers out of a foundry and they get packaged into chip and goes into a product on a printed circuit board and finally comes out as a finished product. As I said, a laptop or a phone or a toy or a Wi-Fi router, energy meter. You can think of any electronic product. They all come out after they go through, the chips go through an assembly onto printed circuit boards. So a very simplistic kind of representation of what you are seeing. So where is India in this? Over the last 20 plus years, I would say close to 25 years, India has matured into a world power when it comes to the design, the top group. So today, India accounts for 22% of the world's design engineering community. 22% of the design engineers worldwide are located in India, where they work for all the global majors like Applied Materials or Intel or Qualcomm, AMD, you name it, Texas Instruments, all the global majors have their number 1 or number 2 design center by size in India, between Bangalore, of course, the leader, then the Hyderabad, and then Delhi, National Capital Region. And now Pune and Chennai are also beginning to emerge as centers of design. So the top row of this diagram is very well established in the Indian ecosystem. And the bottom row, where you get a wafer, then it gets packaged, assembled, tested, and then it goes to electronics manufacturing, and the systems come out. That is where the current focus is happening. And a lot of manufacturing of electronics at the product assembly block is already taking off in a big way. And in the next, I'm pretty confident in the next 12 months, you will see announcements. Already Micron has announced, and a few other majors are going to announce their assembly test. So what constitutes the bottom row of this diagram? So that leaves only the middle row of the diagram to be addressed in a big way. And as you can see, the wafers, the starting point is stand, and it finally ends up as a wafer where electronic circuits are implanted onto it through a process called photolithography. That's where companies like Applied Materials come into picture. And the tested wafers are the ones which comes to the bottom row, where what we call the assembly test, marking packaging of chips, then the product assembly, and the final electronic system comes up. So India is well established on the top row as far as the design. It's becoming very predominantly competent in the bottom row of this diagram. And I'm sure within the next 24 months, we will see foundries, which essentially constitute the middle row of this diagram, also taking shape. And it's not a bad thing. Of course, you can always go back and say that, yeah, India was already producing chips way back in 1980s in Bharat Electronics with license from RCA and 5 micron technology, etc. Yes, we were. But then the primary factor for not that growing into a mega business like the TSMC of the world or the global foundries of the world is a huge capital investment that is required. And that's where India took a pause. But today, particularly after the disruption that has been caused by the pandemic, where non-availability of a single chip which could start an engine, trucks were lying in the warehouse, unable to get shipped to customers, which was economically impacting the country. So we are working towards that, and that will get fixed. But it's not correct to say that we are too far behind, because we are a world power in design, and we are almost getting there when it comes to the chip assembly as well as the product assembly. I'll stop here and let others express their views. Thank you.
Thanks so much, Krishna sir. I have a couple of questions on that slide, but maybe I'll take it up in the with the next question. Yogesh, your thoughts on this?
Yeah, I think already Dr. Ashwini and Krishna have really explained right from demand to demand, and then I think Krishna really put it from the 3 rows, covering the ecosystem right from the design to the final product assembly. Where India stand, obviously they've been much more in the industry for a long time. From my perspective, where I see, because I'm coming from a technology background, where I see the market more, where it is heading, where the demand is getting generated, what kind of technologies are shaping up here. And from that perspective, I would say, as you all know, the AI becoming the buzzword with the recent OpenAI, Microsoft, and the leverage it has taken a more and more
Yes.
dynamics in the market,
Yeah.
like
Quite
AI.
something.
Yeah, it says that AI is just becoming much more buzzword, even more, I would say, in the real terms, because somebody is putting the big bet, like from Microsoft guys. Having said that, as I say, I'll try to give some perspective from the where the demand is coming and how the demand is probably getting supported by the Indian ecosystem, and are there gaps and what need to be done. So I'll take a automotive example because that's where I'm coming from, most of my experience. So in the automotive, definitely if you see now, with the more electrification, more autonomous, more connected kind of a train in the automotive, the number of ECUs have gone probably multifold, okay, right from the earlier few tens of ECUs to the hundreds of ECU. Now, literally, we are talking about within a car. So it's become a combination of hardware and software, and then obviously the hardware is becoming much more needed. And when you say needed, it's much more in the automotive as a mass scale. They would like to have a much more efficiency in that semiconductor hardware performance, or both in terms of the supply chain challenges. But where we see that with the AI coming into the picture in all these connected electric or autonomous kind of a trends or the technologies, where earlier the trend was running these algorithms on the normal CPU, then more to the GPU on the cloud. But then we see more and more development have happened in the technology where we have a ASIC and FPGA kind of a processors are available, and that's where with AI becoming much more prominent, now there are specific neural network or AI accelerator kind of chips are getting developed. Obviously, these chips are ensuring that you are able to do that all the processing at the edge rather than sending all the data to the cloud and then processing it there, because earlier it was required because there was no processing power with then that small compact size and then even the capacity wise. But now with those AI accelerator, very smaller compact chips, you are able to process that high-end neural network models. And then that's where the trend is moving from the cloud AI to the even edge AI, essentially. And when you talk about edge AI, obviously it helps you to ensure that you have a real-time, quicker response because you're processing the data within that automotive quickly rather than sending it to the cloud. Because here in India, obviously the network connectivity may not be 100% across with the same bandwidth available. So that latency part and many other parts, and obviously the cloud is not the free thing. So you need to have a lot of connectivity charges, the cloud infrastructure, the let's say storage costs, and so on. So with that, those are the kind of some of the challenges from the cloud AI, which is where everybody is looking at how do we leverage this edge processing units on the AI neural network models within the vehicle. So that's edge AI is one of the bigger trend, and with that, the thing here where I am seeing some of the let's say the gaps essentially in India. One is the chips, let's say the technologies are available, but now that technologies need to be implemented for the Indian or for the Indian as well as the local application, whatever you would like to implement it. And when you talk about that software and hardware integrations, okay, there I see there is a gap in terms of there are very few companies who are capable of implementing and integrating that hardware and software to the most efficient way overall. So very few engineers or few engineering companies are able to really do it, and that's where we need to really depend on the outside players to come in and help within that integration and then leverage those technologies further. So with that, the background, I would say that India is obviously gearing up in that, and then the more, if you say on the automotive side, the tier one companies in India who are producing all the connectivity, electronics, like say battery management system, or the motor controller, power electronics controllers, everybody is trying to now come to the level playing technology where they are not able to just support the domestic demand, but they are also trying to become a global export house. And that is really great thing because they are able to now become a global suppliers. And hence, I would say that the technology is enabling the Indian tier one ecosystem to build those kind of a capabilities and then export that kind of a final solution, at least like building up. And as you've seen that the EMS players have really got shoot up with the big demand, right? Because everybody want to say that, okay, here because of our FAME subsidy, because of our XYZ government incentives or the policies, now everybody would like to have a local sourcing, local supply chain established for the at least the final electronic components, including right from the panel or board box build-up scenarios. And I see that the volumes are really picking up, and which is ensuring that how we can leverage, even as Krishna or Ashwini said, that the even if you could do that local complete fab or the foundry setup, then probably we will be able to not just capture, as Krishna said, the first design that is already there. The middle layer was kind of if you could do it, the end demand piece and the EMS and the manufacturing, the product assembly, that piece is already established. So I think from that perspective, demand to demand, I would say, or design to demand perspective, the middle piece is where we need to add a value, but also up the value in terms of integrating the hardware and software, having that best efficient integration is where we need to gear up as well. So yeah, probably that's probably the broader perspective from my side.
That's very insightful, Yogesh. Thanks for adding your very, very thought-provoking, thoughtful perspective to the discussion. Pietro, welcome to our panel. Where are you joining from? India? Are you joining from Italy, back from the headquarters? Where are you joining us from, Pietro, if I may ask?
Yeah, from headquarters. Yeah,
yeah, from Italy.
From Italy. Yeah.
Wow. Okay.
Just I don't know if I should explain a little bit what Marpos is doing.
Yes,
because,
please.
Marpos is coming from automotive experience. We have this year we have celebrated 70th of Marpos, so we have 70 years experience of doing what basically. We design. We are in metrology. We are in metrology, and we have applied our sensor. So we design and produce sensor and automatic inspection machine, mainly for automotive. We did it for many years, and we are continuing in doing this. Since many years, more than 20 years, Marpos, it is a worldwide company. So headquarters are in Italy, but indeed most of the people and most of our products are sold abroad. And in India, we are in India since many years. Hanish, probably you can tell better than me how many years we are in India.
So we started in India in early 80s through a distributor, but now we have our direct presence since 2007, and we have 5 offices.
Yes, so India is for Marpos is a really important country, important market. Me and Hanish, we work together to improve, and we work directly to improve the Marpos presence in electronics and semiconductor industry. So Marpos, what did in the past 20 years? Try to focus the attention on how to use our know-how in different sectors. So now we are deeply involved in since 20 years in semiconductor industry, but through what? So Marpos history comes from machine tools. So we know Marpos is known worldwide for the sensor applied and used inside machine tools. When I speak about machine tools, I speak about grinding machine, lathe machine, machining center, and so on. So, which is the connection with India market and with semiconductor industry. The connection with India market, you know better than me, is because India is very strong in designing and producing machine tools for the local market and export a lot of machines. So there are big names everybody knows, like Micromatrix. I probably, Hanish, you can do the list better than me. And so the connection to India is mainly with machine tools for all the machine that cut metallic parts. Of course, with the connection to semiconductor is what? Is mainly for Marpos at least started for the grinding machine. So are the machine that are used to make the wafer thinner. And Marpos since many years, and we have started with probably the most famous company that is developing this kind of machine, this Disco Corporation in Japan. We applying contact gauges. Contact gauges to measure the thickness of a gauge during the thinning operation. And since then, the second step for us was to apply no contact gauge inside a machine that indeed is not really an easy environment to apply an optical gauge. And we succeeded to do this. And we were able, probably Marpol was the first company applying an interferometer inside the machine. Able to control the thinning operation till a minimum thickness of less than 100 micron till 10 microns. So our experience comes from that, from machine and the connection to semiconductor industry is through the machine tools. So grinding machine, thinning machine, and not only, because if you look the picture that in this is very interesting that showed Mr. Morthy. There are a lot of machine tools to produce the plain wafer. So we are speaking about the slicing machine for ingot, and the next step is the lapping machine, polishing machine, and grinding machine to make the wafer perfect on both surfaces and on the edge side. Then the next step, other machine we are involved are a CMP machine, and a very important front end industry. And then after the wafer is prepared, the next step would be the thinning operation, so bag grinding, and then the dicing machine. So Marpos, since many years, is targeting those type of machine, proposing sensor to make metrology, inspection, and monitoring those machines. So we started from there, and I think personally that being India industry very strong in machine tool design, this should be also a starting point for India. I don't know if Hanish, do you want to ask something more?
So thanks, Pietro. As Marpos, we are quality and process control equipment supplier during and after the machining process. So we are basically the quality partner to the machine tool maker and the manufacturer.
Thanks so much, Anish. That was really a valuable insight. My next question to the panel actually stems from the first one, and this is a point that has piqued my curiosity and intrigued us at the magazine and the readers for a very long time. And I'm talking about the consolidation, the concentration in the semiconductor manufacturing supply chain. Now, we all know that all industries have this thing, they follow the Pareto's principle, the 80-20 rule. There is always consolidation, concentration in life, wherever you go. But the semiconductor industry is one of the most extreme cases of this, where, for example, most of the manufacturing is concentrated in one part of the world and with a few number of companies. And it's not just India, wherever India's position on the value chain, even the US is trying to entice manufacturing back to its shores. Obviously, the US invented the technology, and at one point, a few decades ago, it used to produce 40% of global supply of semiconductors, and now it does about 10% with the CHIPS Act, which was passed in the bipartisan bill that was passed in 2022, which gives about multi-billion dollars to attract. Even that is taking its time to do the magic. So my question to Dr. Ashwini is that what is this phenomenon and why does this happen at such a point, the consolidation of manufacturing, for example, with companies like TSMC, and countries and a country like Taiwan that does about 60% of manufacturing in the world today. Why? What are the reasons behind it? I'm sorry.
I think the reason why it went to Taiwan is their overall strategic planning. They actually were able to force, they were able to leverage the evolution of the fabless industry, and they took a concentrated approach to, picking up that demand. Uh, that is the key thing. If we want to replicate a success, uh, we have to very carefully recognize where they are, define our playing ground, and build our strategy along it. Where it is such a competitive global scenario, I think the key thing always boils around to 2 points. One is, how do you make sure you're getting the right yield out there? How you make sure you're getting the right load on the manufacturing facility? It's not an easy thing. I think uh, just to share a simple example, I did an analysis of the loading that can be done on the fab in 2014. I see one part of it taking a shape now with IDEMIA. IDEMIA is doing the smart card manufacturing here. They are the world's largest smart card manufacturing in India, in the world. And they are doing about 700 million smart cards a year. Okay. Uh, you know what that means? They have a load of 2,000 wafer starts a month. 2,000 wafer starts a month. Each of the wafer will have 30,000 devices on it. Okay, can you imagine 60 million devices being made from 1 month's production on 2,000 wafers? 24,000 a year is loading the IDEMIA factory. It's the world's largest factory. It being here is strategically relevant because 2,000 wafer starts a month is almost 1/10 of a loading of a 20,000 wafer starts a month fab. Okay, so you really have to start thinking in terms of how do you address a large global demand and you are able to execute it, efficiently. It's a question of doing it technically right and doing that demand aggregation and managing your supply chain to play along with you. Today, TSMC Taiwan has that advantage. They have a technology leap, they have a supply chain leap, and they are taking the demand from all of us. Okay, if we actually play smart, we can create our own opportunities. Okay, our demand that we can aggregate and trap for our factories. We can actually look at going beyond the local demand to a global play, like, if we have somewhere like IDEMIA, they're obviously shipping to India, but they're also shipping abroad. That becomes an advantage. So you're getting a feel of how a combination of these factors can enable what's happened elsewhere. If you actually start looking at it, the entire game plan is to create a end market focused policy that is able to leverage India's strength, which could be its low labor cost, high talent, weaker currency, and mitigate the weaknesses, which could be the high capital, lower risk-taking capability, lower intellectual property capital, whatever. But it is not impossible. We can do it. We have to actually define the niches that we're going to trap for our opportunities. So that's the key message I can give.
Thanks so much, Dr. Ashwini. Krishna sir, are you there? Krishna, so the question that I had on that's wonderful slide you presented, so was that there were 3 rows of specialization of the different areas of manufacturing supply chain. Now, from India's perspective, what would be the parts that we need to focus on? I'm so sorry. What are, where do our strengths lie, sir? Which parts, and which parts do we need to focus on, even though, because of the fact that we can not only do better there, but they are they are gettable, to, for the lack of a better word, if you know what I mean, that we can really make a difference, bring value from what Dr. Rashmi said, that the skills that we have, the infrastructure, the currency, what part of that slide can we really add value to?
Okay. See the top row, if you can see my cursor, is something where India today adds approximately $50 billion worth of design for the world, either in the form of captive design centers of multinational companies or design service companies collectively contributing in excess of $50 billion of value here. Now, as Yogesh also said earlier, this part of the ecosystem or the supply chain, where post-wafer fabrication up to the finished electronic system, the work is progressing at a very fast pace. And think about it. The first row and the third row are where you generate the maximum value and margin by its intrinsic nature. One is highly intellectual in nature. The other is much closer to the end product in nature. Now, a wafer that you see in the middle row, of course, it's very important to the whole ecosystem or the supply chain. But today, I'll show you the next file. If you can see this, the worldwide foundries collectively account for almost 95%. And how many of them are there? 5 or 6, or maybe all put together, maybe 7 of them. That's about it, right? This many of foundries manufacture all the silicon that gets made in the world. And there are a couple of internally captive foundries like Texas Instruments or Intel. But leaving that out, for all the other fabulous companies, these are the foundries where they get made. Now, how do we get into a piece of this pie, of the foundry pie? That, as I said earlier, will get solved in the next 2 to 3 years. You will see at least 1 or 2 foundries coming up. But if within that, the newer generation ones, like the silicon compound semiconductor fabs, silicon carbides and gallium nitrides, are the ones which probably will happen first, not the conventional silicon fabs or silicon foundries. The reason is, number one, we have pilot plants of these compound foundries already in the country, and we are making prototype devices today. So manpower availability will not be a problem when it comes to foundries in compound semiconductor domain. And even if the demand picks up pretty fast, I think we have pretty good schools where the talent can be generated. So going back to my first file, I think the breaking this jinx of manufacturing wafers in the country probably will happen in the next 2 years, or maybe at the most 3 years. But when you look at the value proposition, I think the top row and the bottom row provides the highest value. A wafer in 180 nanometer probably will be today costing at $600 per wafer. At 28 nanometer, it may be close to $2,500 a wafer. So if you're talking about 40,000 wafer starts per month, that's about 500,000 wafers per year into $2,000, $2,500. You can do the maths. It is still one foundry may not be able to cater to all the requirements of the country, because we talk about 80 billion going up to 110 billion semiconductor demand. So dependency on foundries globally in other locations will continue for quite some time, but India will climb that ladder or start climbing that ladder in the next 3 years. And this is not difficult. I mean, go back to the time when Suzuki started making cars in India. Even the nuts and bolts were getting imported from Japan. And today, with the exception of maybe the very highest end German cars, including the engine, everything gets made in India. So we have done it in the past. And we are doing that, beginning to do that even for aircraft So I'm pretty confident that will happen. Thank you.
Wow. Thanks so much, sir. This brings one question to my mind, and if you could excuse me, I would go back to Dr. Ashwani and then also come back to you, Krishna sir. Now that you have, I'm getting greedy because of having thought leaders on this panel. Uh, Dr. Ashwani sir, see this entire value chain that Krishna sir presented. Now, a lot of us, including obviously the government, also is focusing on the manufacturing part. Whereas, sir, you know much better than a lot of us, your organization being heavily, majorly into R&D. It's Applied Materials is not only known for its machine tools, it's known for its R&D, research and development into this as well. And that's where the real action lies, because the whole fight, if I may put it that way, is about IP. Because of geopolitical things and all of that. Now, is it possible, Dr. Ashwini sir, for India, for us to have a go at the higher end of the value chain, the design, the IP part, the research and development part, sir?
I totally believe in that. My company has bet big on it. We started small with one program that was announced by the government, the SPECS program, and then expanded our engagement out there. The latest figures are we expect to invest about $400 million in the capex expansion of our R&D infrastructure in the country. We have added about 1,500 people in the last 1 year. It's happening because we see the talent and the competence mix reaching a stage of maturity that we can take off on a larger scale from India. So I think, and we're not talking of design, no, we're not talking of soft design, we're talking of hard design, where we're actually working on materials at different geometries, on different structures, creating, robotics, addressing different precursor gases for, performing, very specialized operations in highly controlled chambers, diagnosing problems relating to operating in the sort of environments you see in the semiconductor industry, and troubleshooting for the rest of the world those issues, creating new designs, even full prototypes out of India. And that is very exciting. We hold several hundred patents now out of India. And, today, I think it's a very big opportunity. We won't be the only ones. We see motion in that evolving with SCL evolving as the India Semiconductor Research Center. We see motion in that evolving with some of the packaging sector moves being done by the ISM leadership in that. So I think at this point of time, there's absolutely no doubt in my mind that R&D is one of the low-hanging fruit initiatives for our country that we should definitely capture, but we have to execute for it. It's not a straight line on it. We have to execute on it. Execute in terms of the policy. I think the talent itself is good, but there's a lot of execution on the policy front that has to be there.
And what about the design, sir? The design part of the value chain, as you know, sir, the UK, for example, has firmly established itself on the design part, and this is also a part where IP plays a big role. And a lot of people say that India, having the skills and the talent that it has, the software skills and talent, and the thinking minds that we have, could we not have a shy at the design end of the supply chain?
So I submit that design is the next stage of the demand. On the policy front, the country has to actually define an appropriate demand aggregation strategy, create designs for that, and then look at its foray on in the market. It's not got to be a demand satiated by a design at a point of time. It's a demand that has to evolve over a period of time, and designs, a portfolio of designs over the years to make sure that we lead the curve of managing that demand over that period of time. So it's a little more loaded this response? The answer is very clear. If the manufacturing production is competitive only at large scales, you have to have a strategy which starts with the customer and then ends with the customer. I think Krishna can evolve a little more on this, but that is the reality.
Thanks so much, sir. That's very helpful. Answered a lot of questions. Krishna sir, that same question that arose from the presentation that you made, that how about going higher up the value chain, because the skills that we have, the software legacy that we have, sir, and the IP part, sorry, the universities that we have, for example.
Yeah. So the story that's getting played out in semiconductors is pretty much similar to the software story. If you go back to 1981, the software story started with testing of software. So software was getting written in different parts of the world, but they used to come here for testing. And Indian semiconductor story started exactly the same way. More of verification of design is what it started with in early 90s, mid 90s. But today, going back to the point which Yogesh talked about, custom AI chips from definition of architecture, definition of the application requirements, to realizing the chip, testing it and characterizing it and proving that all the functionality that the chip is designed for is happening out of India. It took us 20 years to get there, maybe 18 years, 15 to 18 years to get there. But today, we can define, okay, now for this particular, let's say, medical application, we need an AI chip which can read the X-rays or MRI films or CT films and come out with conclusions to help the doctor with a lot more accuracy. Those kind of chips are getting defined and designed out of India. And similarly, automotive, some of the AI enablement that's happening for ADAS level 2 and level 3, both the hardware and the software. So when I talk about design, I'm not only talking about the chip design, I'm talking about the hardware, software, code design, its integration and validation. All that's happening out of the country. So that maturity has happened. And today, most of the companies, at least the big companies, on an average, they file one patent a day. There are companies which file more, but at least one per day is the norm in majority of the big companies. So IP creation, IP value chain movement, I think we have achieved to a large extent. But are we still comparable to the number of IPs that China files or US files? Probably not yet. But are we better off from where we were 10, 15 years back? Much better off, right? Now, it is not only the design part of it. Now, this is where both Mahfouz and AMAT comes into picture. Now, it is not just the import of those equipments and use of them in a R&D foundry like SCL Chandigarh or the one in Mangalore, Sitar. These are some of the R&D foundries or R&D capabilities that we have, but the kind of MEMS that they are bringing out of these facilities are the ones which are going into the Chandrayaan and Mars mission. They are not getting imported; they are getting made here. So those IP creations and IP validation and the use of these sophisticated equipments. I mean, you think about a 12 nanometer or a 7 nanometer wafer, and if you want to do a back grind of that, the kind of precision with which the back grinding has to happen and where Mahfouz provides those machines, I think it's just not the machine, but the ability to use that and the ability to do the back grinding so that the thickness is brought to the level with that level of precision. I think it's an excellent interplay. So it's just not, when you talk about IP, the knowledge that is required for realizing all these sophisticated operations, photolithography of 7 nanometers, laser direct imaging. I mean, these are some of the places where we are touching the boundaries or borders of knowledge and technology trade. And that's what is happening out of the country. So I have absolutely no concerns on our ability to go up the value chain when the demand arises. It's only a question of how do we drive the demand and how do we respond to the demand is what finally makes it happen. From a talent point of view, we have fairly well managed. I would say we are not scaled big enough. We are still short of good engineers. Always, if I want to find a good analog design engineer globally, that's a problem. There is no exception. So there are some gaps, but it's not very not a big challenge which we will not be able to solve if we put our heads to that. That's where I will start. Thank you.
Thanks so much. A very quick related question, which is fact based. So you said 7 nanometer is where we could reach, and that intrigued me. Is that the bleeding edge of this technology lies at what 3 nanometer now with M3 chips, Apple's latest. Where do we stand here?
Yeah, 3 nanometer is getting prototyped. Productions have started in 5 nanometers, and 2 nanometer is in R&D.
Okay.
And volume productions, big volume productions are happening anywhere between 16, 12, and 7. And 5 has just started building some capacity in 1 or 2 fabs. I think a couple of fabs are now producing. TSMC, of course, Samsung, of course. They have started producing 5 nanometer wafers. But the bulk of the FinFET nodes are between 16, 12, and 7.
Okay. And where does India stand in the entire thing?
Well, we haven't got to the wafer manufacturing yet. That's where
in terms of design.
Yeah. So, but design-wise, yeah, our engineers design 5 nanometer chips today. Our engineers lay out 5 nanometer chips today.
Wow,
and they do tape out 5 nanometer chips out of India.
Okay, thanks. It's very informative. Yogesh.
And then, yeah,
finally we meet.
No, I thought of adding up. I mean, it's really great insights from the Ashwini and Krishna.
Yes.
I mean, I wanted to have another thought process here based on my experience coming with some of the applications here, and then how do in the automotive industry. One of the key factors is the supply chain and the strategic engagements with this fab. As we all know, the fab is not getting produced here. We are still depending on the TSMCs and other parts of the. I mean, from the chip perspective, we are still dependent. But then currently, I'll just give you a couple of examples. One is I've been engaged with one of the company where they wanted to have a China plus one strategy for even all the electronic component manufacturing. And then obviously they wanted to look at, it's a multinational company based out of the US. And I was talking to one of the sourcing team in India. And then the experience that comes here is still, if you talk about getting that complete electronics box build-up happening in India, there is a competition coming from East Europe, even the Southeast Asia countries. And then when it comes to the India, one of the challenges how the EMS players have got a strategic engagement or establishing the base rate contract assigned with these chip companies. Okay, and that makes them much more competitive. And I would say that's another game which makes the Indian ecosystem to go more competitive in the world map. Essentially, it need not to be a purely, let's say, as we say, we're going on the fab route, making the good progress. But then even this last end of this row where the first row we are designing it, last row we are now with a lot of startup companies, with the AI particularly, they have been able to build the products also associated, and then to build that software and hardware products, ultimately somebody need to manufacture and make it a more global scale solutions. In that case, then when you look at getting it manufactured from the EMS guys, the way we see that there is still that competitiveness is slightly not there compared to the East European guys or even Southeast Asian guys, depending on how how the Indian players have been able to achieve the strategic supply chain contract established. So I'm just putting that one particular part here as a thought process. That's my experience. But as Krishna and Ashwini said, that I think in terms of this new, not just the established incumbent players, I think there are a lot of good startup companies have been really able to build a good uh, uh, products or solution integrating the software and hardware in the electronics. And there are a lot of use cases enabling them to go global. It's just that having the complete supply chain ecosystem, if it has been in India, it could scale up the penetration of Indian ecosystem into the global map, not just from the supporting the design services or just playing the EMS game, but also delivering the solutions and become a product owners as well. So yeah, that's my just thoughts based on my experience.
That's very, very helpful, Yogesh. Thank you, thank you.
Anand,
And
I would like to add.
yes, sorry.
Yes. So when we Krishna sir speak about the nanometric level, so
Right.
there is where we come into picture. And when we
Okay,
see
okay.
the manufacturing process in the row number 2 and number 3, that is the ingot slicing, wafer lapping process, fabrication, the back grinding operations, then we have a solutions.
Okay,
And we are
okay.
continuously working on the R&D to develop more and more solutions, and of course also applying for the patents in these manufacturing processes.
Thanks so much, Anish, for that info. Dr. Ashwini, you wanted to
I just
say
want
something?
one thing to Yogesh's statements, and that is that EMS is actually an advantage for us. It's building up very well for the nation. Imagine a situation where there were so many naysayers saying no manufacturing can happen in India, and EMS is again proving that it can happen. We've done $25 billion of electronic exports last year, and it's actually a 49% growth that was seen last year on year versus 22. But let's not go by the numbers. The fact still remains. People have all sort of myths about what is happening on that front. Uh, Yogeshji, it is a fact. One has walked through the floors of so many of these EMS companies as industry leaders and engaged stakeholders, VVT, and growing from 300 crores to 1,000 crores to now 22,000 crores. Or you take SGS Sirma, two,
Yeah.
300 crore companies combining should have been 600 crores, became 1,200 crores in the first year. Second year, they are actually crossing 2,500 crores. Okay, your Foxconn factories, when you walk in, you are amazed by the sort of infrastructure that is come there. It's to say that there is no value add or low value add. I don't think so. They are transforming our manufacturing landscape, and they're building a huge opportunity for the upstream value chain. So we have a challenge there. We have to nurture that upstream value chain. The components have to come up, and then really the magic will be so much more impactful. We are there. We are in
Yeah.
the right policies.
So I,
Years have been amazing. The leadership has been very, very sensitive and directive, but it is not the end. I think there's a lot that is being missed out that we'll have to fill.
yeah, I mean, I totally agree. Ashwini here is, I do see that this such a great level of acceleration has happened. I'm just trying to get to the point where it's still there is a good gap when it comes to the world competitiveness map, essentially, even from the EMS value addition per se. That was one of my comment here, but I do see that already. I mean, that curve has really been on a sharp, essentially, and then EMS is enabling a lot of local players to be able to go just not serve the domestic market, but even globally, essentially. So yeah, I agree with your comments, and then I think it's on a good path.
The
Thanks so much,
additional
Yogesh.
point I would like to add is companies, EMS companies who were probably running one shift with a little bit of struggle are now running 3 full shifts. and they are on allocation for their customers. Now, that's a transformation which has happened over the last 18 months. Now, coming to the equipment demand, which Marfos talked about, it's only a matter of a few months, and then you will not have time to breathe once all these ATMPs and OSATs start placing their orders for the different equipments. You will start seeing this best case in Q1. More realistically, I would say Q2 of next financial year, 2024. And then you can forget your vacations and things like that.
That's your
Pietro,
enthusiasm is
for the
contagious,
motivation.
sir. Thank you so much. That's
And
Pietro, you want to add? Yes, sir.
Without any doubt, I will tell you, Casarola, you will shift your headquarters from Italy to Bangalore or Bombay or something. So
Yeah,
Harish,
please do
start searching house for you.
Pietro,
Yeah,
you want to add?
But of course, you are for sure the person present today are more experienced than me. So my perspective is very small and focused on Marcos' experience or machine tool for semiconductor production. So I can just tell that Marcos is able to support any Indian company that want to invest in this sector. So I am mainly speaking on the middle line of Mr. Morty. So for wafer producer or chip producer and back end operation, we are able to support any company that want to be involved and design those kind of machine, and also for the end user in case they want to improve those machines, so the current production. So we are doing a lot of retrofitting to improve the current production at the end user side. So I can say that Marpos too is also investing money in developing more smart sensor and able to have a smart control. So we come from 4.0 industry, automotive industry. So this is our background. So all our sensors are aimed to be smart, to be easily integrated inside the machine. And starting from this experience, we are focusing our attention on how to control and to measure new materials like silicon carbide or gallium nitride. So let's say that any mechanical process aimed to work those materials, let's say that Marpos is ready to supply something to support any OEM that want to do as the goal to develop machine for machine tools for semiconductor process, to improve semiconductor process. Then Marpos is also now is investing, and because we see a very big potential on the packaging industry. So packaging is very interesting industry, and packaging is going to become more complicated, and so metrology. Metrology machine to check the proper packaging or to control for instance, the die attach machines is one of our targets. I think this is all from our side.
Thanks so much, Pietro. Yogesh has to rush somewhere. Thanks so much, Yogesh. I had so many questions about AI. My readers are not going to forgive me for not bringing them up, but that's for later. I'll take a rain check from you. Thanks so much for being with us.
Thank you so much, Anand. Thank you, Dinesh, and the team. And it was a really pleasure talking to the experts, hearing their views. And yeah, look forward to catch up again on the AI topic for sure. Thank you, everyone. Bye-bye. Sorry, I have to leave for some other meeting soon. extremely sorry.
Have a good day.
Have a great day.
Thank you.
Bye-bye.
Bye-bye. Bye-bye. Right. So, Pietro, sorry for interrupting there. My follow-up question to you and Hanish is that what are the latest trends that you are witnessing in semiconductor equipments? One is globally. One part is that globally, what are the trends you are observing, and one is the Indian trend. What is that you are seeing here in India? Pietro.
Well, as globally trend for us, we have been pushed by our customer to develop sensor to measure a very thin layer of silicon. So so our next target is to grind for our customer to grind silicon for thin silicon thinner than 10 microns. So 10 could be 5, could be 2, and less than 1 micron too. So we are developing sensor aimed to control those thin layers. And this is a general trend. So layers, thin layers measurement is something that it's a requirement not only for let's say grinding machine, but also for everybody producing electronics. So flexible electronics. So speaking a very thin layer like tin oxide or any kind of materials that is applied on flexible electronics. So that's the trend I see, and Marpos is working on this in this direction.
Anish,
And
what
yeah,
are the
and
trends you see in India?
yeah, so in India we are just starting. So, but to demonstrate our commitment to Indian market, we have already taken a membership of ICEA, that is Indian Cellular and Electronics Association, and IESA, that is Indian Electronics and Semiconductor Association. And globally also, to demonstrate this commitment, Marpos has acquired a couple of companies who are doing nanometric analysis uh, in the semiconductor, LED, and manufacturing industry, that is still from France, and Solarius from USA.
Okay. Now we just have time for one more question. I'll take up a reader question. Somebody from LinkedIn has asked a couple of questions. Mr. Raman says that about this is a policy question, so please feel free to share anything that you feel comfortable sharing. So there has been the question is that there has been a few semiconductor policies on part of the government that is mostly based on incentives to be provided to the industry. Uh, Although there needs to be some focus on the infrastructure part, on the energy supply, for example, semiconductor is very energy sensitive. Manufacturing is so. What are the things that are being done which are good? Number one, and what are the things that could be done better from a policy perspective? Dr. Ashwini, your take on this, please.
I think the government has taken cognizance of the requirement of the industry, and a holistic mission mode approach has been put up uh, with the push from associations like ISA, ILCINA, and today they are focusing on the entire value chain of the semiconductor industry. Unlike the previous approach, it is covering design linked incentive, it is covering production incentives for certain types of industries, it is focused on component industry, it is focused on the semiconductor manufacturing, and overall the impact is visible in the marketplace. Today, if the issue is how do we get that aggregation and the advantages of volumes, that scale is being built up in the policies by creating clusters in select states. Already you can see electronic manufacturing concentrating in UP, Noida area, in Gujarat, in Karnataka, in South Tamil Nadu. So these are again evolving as places where there's a cluster strength building up for enabling the industry to show its teeth with a volume operation. I think in terms of additional initiatives, it has to actually, the government has to take care. The response from the global market is at its peak right now. Okay, there's a huge geopolitical, benefit that we are reaping, but we have to actually make sure that we execute for the anchor accounts that are coming in. Make sure that the policy comments that are made are actually getting executed painlessly. And I think the future is very exciting. We at least have got a foot in the door now.
On the infrastructure part, sir, do you feel there needs to be some emphasis? Because this industry is very infrastructure sensitive more than other industries. And by that, I also mean energy, for example.
I think the states have their strategy on it. State of Gujarat is energy surplus. They're committing seamless power to the projects that are going there. State of Tamil Nadu has said that they will provide for 2 power lines to build redundancy to any project that goes there. So I think the right approach here is we just have to take a plunge and do it. There's a lot of myths. Okay, a lot of times people think that these are big showstoppers. They are living in the 70s. The current stage of infrastructure is not all that messy. Okay, you have classic examples that we take Singapore. It has no drinking water of its own. It has a fan. We have a situation where we are much better geared in India than most people understand. Perceptions of a few decades back should not create our image of the future.
Yeah,
Thank you.
I
That's
would
very
like to
encouraging,
add
sir.
to
Krishna, sir.
that.
Yes, sir.
I would like to add to that. IESA is now conducting an audit of the quality of power, quality of water, the infrastructure, transportation infrastructure. Because, for example, if you need to bring a precision photolithography equipment from the nearest airport to the fab, you need a road surface has certain specifications. So that's the level of infrastructure that is required. So we are doing an audit with an international agency on these aspects, and we'll publish the report when it is available, maybe in the next couple of months. But I can say that the initial study shows that some of the states which Ashwini mentioned, states of Gujarat, Tamil Nadu, etc., are doing extremely well. The findings are very, very encouraging. So we have come a long way off. Okay, if you take every state in India, probably yes. We cannot say that with the same level of confidence that you go to any state, you will get the same quality of power or water. But there are states who have taken this as their mission to provide the Telangana is another state, right? So there are some states where there's significant amount of concentrated focus and actions on the ground are being taken to enable the infrastructure to be of world-class specifications. So it's happening, right? But the crux of the issue is bringing all this together. The policy support, the infrastructure, creating the talent, creating an ecosystem where the demand drives the manufacturing and manufacturing in turn. So, for example, if you take Singapore, Singapore is probably the biggest warehouse of semiconductor components in the world. And they just add a clean 5% margin by just bringing semiconductor assembled tested products into their warehouses and then shipping it out from there to all the EMSs in Asia Pacific region. So this is a very, very simple business model. But the kind of infrastructure that is required for doing that seamlessly, because they give assured kind of services, like, if your wafer comes in today morning from, say, Global Foundries in Taiwan, or sorry, TSMC in Taiwan, within 36 hours, the finished tested chip will go to the warehouse in Singapore. And within 48 hours, it will find its way to the nearest EMS where an order has been placed. So they give those kind of, assured turnaround times and, inventory management, managing the cost of inventory. So these are the finer aspects of this business that India has to develop. But if you purely talk about the raw infrastructure like the power, water, road infrastructure, ports, international ports, and airports, I think we are almost there.
Thanks so much, sir. Pietro, your perspective on what could be done better from a policy and infrastructure perspective, from what you've seen and you know about Indian semiconductor industry.
Indeed, I have nothing to add more of what you already said. So I have no comment indeed about India. Indeed, for Marpo's experience, India is a new market for semiconductor. So we are just starting. Our presence is mainly in, we have experience in, for sure, Japanese market, Taiwanese market, the Korean market, Chinese market. We have a lot of experience. We have a strong presence in China currently, so we are facing the same issues and the same targets. Probably India is targeting today. So that's let's say we are following what you're and we are trying to invest more in Marpo is trying to invest more in India because we want to support you. We want to also to share our experience with you.
So much, Hanish.
So we see there is an intent of the government now. There is a PLI in place. There are companies coming into India. There is a consumption story, be it mobile manufacturing, be it consumer electronics, be it a PLI for the IT hardware, automotive needs semiconductor, biomedical equipment needs semiconductor. So we see there is an intention. This is the right time we are starting now. Of course, government policies will need amendments and changes from time to time depending on how the need arises.
Thanks so much, gentlemen. This is a lovely discussion. This went way better than at least my expectations, and I'm sure of readers' expectations as well. And all of that credit goes to you, gentlemen, for sharing these unique and valuable insights with us and staying with us for this hour and a half for this scintillating, riveting discussion that's going to go a long way. Thank you so much, gentlemen. Have a brilliant day ahead, and look forward to having you again for another talk.
Thank you for having us.
Thanks, Pietro, for joining us.
Okay, thank you.
Thank you.
Pleasure
Good day. Good day. Good day. Bye-bye.
Have a good day, everybody.
You too, Pietro.